Let me turn the lights off and then we'll get going. So this week we're going to continue our exploration of learning how to do 3D modeling inside of Modo by talking about the materials and texture system. This is just going to be part one of a seemingly 20-part conversation that we have over the conclusion of this semester. There's a lot that goes into drawing our images and on the rendering side of things. So the entirety of our day today is going to be spent discussing the materials and texture system inside of Modo. This is not the only time that we're going to talk about it, but it's just the first part of a much, much larger conversation. This is probably one of the most complex parts of the entire pipeline. Making models in the larger scheme of things is kind of relatively easy, right? It's very sculptural. If you're a person that comes from, that kind of three-dimensional environment in your mind and you're used to building things either in the real life or using a computer, the modeling part is easy. What's difficult is the painting part of it. The application of all these materials and textures to yield a higher quality result and ultimately achieve that realism that we're trying to strive for in the render itself, okay? A lot of folks don't put a lot of emphasis on the materials and textures. I do. It's a big, big portion, okay? It's more than half of what the person is going to see in the final render. Models are great. Being able to make the geometry is awesome. That's, good for you. You can make the model. But the model is just a whole bunch of polygons, edges, and vertices. We need to apply a whole series of materials and textures to create a compelling render. At the end of the day, it's all about how it looks, not how it's made or how many polygons it has, okay? So I like to put an emphasis on this stage of the production pipeline as it's really, really important. Before we jump in, let's just kind of touch bases on what the expectations are this week. Let me jump over to renderography.com. Just want to double check, make sure I'm streaming here. And we'll go to our classes section. And here we go. So creating materials and textures. So the entirety of our conversation today is going to revolve around making the diffuse textures for all of our corkboard pieces. Okay. As you might imagine, the homework this week is the conclusion of our corkboard project. Okay, this is what we are striving to achieve. Okay, we're going to go in and start placing all the materials and textures for all the different pieces on our corkboard to create a more compelling render, to create a complete render. Okay, so this is what we're after this week. Our lab exercise is going to give us an opportunity to really dig into the process of applying materials. I'm going to give you this really cool lighthouse scene. And then your job this week is to take all the raw geometry, all the 3D models, and apply textures, do all of them, and create a whole series of compelling renders. So you're going to get your hands dirty applying materials this week, okay? There is some muscle memory that I'm trying to establish here with this process, okay? You need to be very disciplined when it comes to working with textures and materials because the application of these textures and materials is absolutely going to have an impact on the success of your render. Okay, any questions about what we're going to talk about today? All right, we'll come back to all this at the end of class and revisit the expectations one more time. So let's just jump into Modo and start getting going here. Now I'm going to make a couple things in my scene here. Yeah, let's just do this. I'm going to make a really big place for our guy to hang out. Let's do this. I'm also just going to lower this plane down ever so slightly. There we go. So that a number of these unit primitives can be easily seen in our three-dimensional scene. All right. And let's just do this. All right, something kind of like that, and I'll put a cylinder kind of chilling in the background, and then the last thing I'll load in here is just a simple cone. Oh, we can't forget the donut. All good demos involve a donut in one capacity. I love donuts, by the way. Man, they're so good. Why do donuts need to be the most amazing thing on the face of the planet? Say again? So good. All right, let's just do that. Very, very simple scene. So if you're playing along, I encourage you to do so. Let's just see if everything's lined up. Yeah, that's good enough for government work. So put that in there. unhide my cylinder. Just move some of this around a little bit, and I'm just going to create a cool little compelling scene. That's it. That's all I'm after. Okay, so this is where I am. So I've just created a very, very simple scene that will give us an opportunity to play around with a whole series of materials and textures inside of Modo. So if you're following along, they're just unit primitives. You already know how to make unit primitives, so make what you see on the screen and follow along. Okay. Now, a number of you have already kind of stumbled upon the process of creating materials and textures for your shapes inside of Modo. It's really quite easy, but there is a procedure that we need to follow, and there's a couple steps that we have to honor to ensure that we're applying our materials correctly. Okay. There's a method to the madness. There is a system, that's in play here that determines how all of our polygons within our scene are evaluated by the render engine and are drawn. So as you can see on my screen, I've jumped over to my render tab, and we're going to spend almost the entirety of our day today in the render tab. We're going to talk very, very little about 3D modeling today. It's just all about rendering and the application of materials. Okay. So in the render tab, it's really broken up into kind of basically 3 or 4 major areas, depending on how your brain thinks. This is how it's going to look like on your screen. You know this from our previous week's conversations. We have a preview window of the render up at the top. Now, is that a final render? No, it's just a preview, right? In order for me to actually create a picture of my scene, what do I have to press? Yeah, the render button, the big render button at the top of our screen, this guy up here. Boom, hit the render button, and then a new window pops up, and you can see that the computer is beginning to evaluate my entire scene, and it's physically drawing the pixels. This is the final quality here, full quality, once we hit that render window, or render button, in the render tab. So immediately south of our preview window is just an OpenGL window, OpenGL viewport, that has the render camera properties already applied to it. So it's kind of an OpenGL version of what the window is seeing. Now this is a standard OpenGL viewport, so if I wanted to, I could hit this first button in the upper left-hand corner of the OpenGL viewport and choose maybe a different perspective. So I can definitely continue to use this as a work area. I'm not limited or restricted to only seeing a duplication of what the camera sees in the preview in the bottom viewport inside of this environment. Okay? So we have the luxury and the option of changing the behavior of that bottom window to do whatever we want it to do. One of the really neat things about working inside of Modo is that we always have access to our geometry in our scene at any stage within the production pipeline. So if I needed to go in and make systematic changes to the placement of my little unit primitives within my scene, I can do that even in the render environment. I don't have to go all the way back to the modeling tab to do modeling stuff. I can continue to work downstairs in that OpenGL viewport. That's pretty neat. So we're going to be using this OpenGL viewport down here at the bottom here momentarily to do a whole series of selections. So it is kind of a nice important window to have at our disposal. Over on the right-hand portion of the render environment, there are a whole series of lists and tabs that are really important as we go through the process of applying materials and, most importantly, editing those materials. It's broken up into kind of 2 big sections. This area right here, it's split vertically into two different windows. The top part has a number of tabs, but most importantly is our item list. So we can very easily navigate through all the different items that we have in our scene. Rock and roll, it's pretty great. And then the bottom part is the shader tree, or actually it's just called shading. It used to be called the shader tree, but they've kind of truncated the tab to just be shading. This is the work area for the render window. This is where we're going to be doing the lion's share of our editing. All of the materials that we create, and all of the material groups, and all the textures, and basically everything that's responsible for generating the image is going to show up in this area of the interface. So it's really, 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 really important, okay? The shader tree. This isn't the only place you get access to the shader tree, but it's definitely the easiest place inside of the Modo interface to quickly go in and decode what the rendering engine is doing as it's drawing your image. To the right of that, so the kind of the rightmost part of the interface, all of this stuff over here, these are just properties. This is just an expanded, what in the world was that? Someone's alarm going off? Should we all run out of the building screaming? Is it the end of the world? So this is just an expanded properties tab. hanging out over here on the right. Just they made it full screen so that we get access to the entire list of properties in the interface. With that said, let's go through the process of applying materials. Okay. Is that something in here? That alarm going off? Because that's really throwing me. Now would be a good time to turn it off. I know, right? The worst time for anything to go off is like right smack dab in the middle of a class. Or I hate it when when someone's cell phone goes off like in a movie. Oh, that drives me absolutely crazy. They answer it, right? And you know, the unfortunate thing about cell phones is that they're all like touch phones now, right? And so like someone turns their phone off to like answer the voicemail, and the screen is so bright it like totally illuminates the entire theater, and you can see like what they're updating on their Facebook wall and stuff. It's just, it drives me absolutely batty. It does. I both love and hate going to the cinema. I love the cinematic experience of the films and the sounds and the super screen, but I hate going to the cinema with people. Because sometimes people are silly. All right. Yes. Yes, absolutely. Yeah, I don't know which 3D app they used in RoboCop, but a majority, if not all, of the visual effects in RoboCop were computer generated. Did anyone see RoboCop? The new RoboCop? Anyone see it yet? No? Just curious if it's good or not great. You say it was good? Cool. Yeah, the old one's pretty great. You know, they have very, very large shoes to fill. The old one was pretty fantastic. So. Yeah, you know, some of those old school visual effects still hold up to this day. I mean, look at everything that was done in like The Empire Strikes Back. I mean, it's just as real as what they're creating these days. So it is. Anyways, okay. Before we really jump into the process of applying materials and textures, I think it's really important to take a step back, slow down for a second, and talk about the technology. Because there is a method to the madness. There's an order of operations that the rendering engine is going through when it's evaluating how it's going to draw all the colors inside of our image. Okay? The shader tree is responsible for figuring all that stuff out. The shader tree is the only element inside of our entire interface who's responsible for figuring out how each polygon is supposed to look when you hit that magical render button. And there's a little bit of a sequence and an order of operations that we need to kind of at least have a little bit of understanding on before we really can become masters at generating some renders. So let me zoom in for a second, and we can take a look at all the components of our shader tree. You can see that the shader tree comes with a number of default elements, and let's just talk about them really quickly. The shader tree is broken up into what I would call 4 major categories. We have the render component, which is this guy, and you can see that you can expand and collapse it. Okay, so this is the render section of our shader tree. This library thing, just forget about that for the time being. We also have a section here whose sole purpose is to separate all the lights and the direct illuminators in our scene. You can see we have one directional light and its associated material. We also have a section here who's responsible for drawing the environment. Okay, we'll talk about that over the next couple of weeks. And then the last section is the FX section of the shader tree, and this allows us to do some really neat particle shading, volumetric shadings, things like that. Those will show up in the FX section of our shader tree. For today, however, I want to focus all of our attention on the render component of the shader tree. Do you have a question? Yeah.
This is probably what we're going to get into it, but the environment will, when you do the environment tab, does it separate your image away from the environment and just does the background for you, like you do it?
Yeah, it's going to do the background for you.
Okay.
Yeah, it's very cool. We'll see that in action here in a minute, for sure. And whatever's inside of this folder, if you will, if you think of it like a folder, is going to have a direct influence on how our foreground object is drawn. Okay. Let's jump into the render section of our shader tree, because it really is the most important. If we expand it by clicking on the dark gray arrow, you can see that there's 4 basic common elements that come with every Luxology scene file. These are the defaults, and they're really kind of important. We want to start our exploration at the bottom. Everything in the shader tree starts at the bottom and works its way up, okay? And at the bottom of our shader tree is a really important element. It's called the base material. The Modo rendering engine works vertically. It evaluates from the bottom and it goes all the way up. So the first thing that the Modo rendering engine is going to look at is the base material, okay? If we zoom out for a second and take a look at how our scene currently looks, you'll start to see the effects of the base material in action. One kind of thing. This little arrow here, this is going to maximize the viewport. I'm going to do this a lot today just to make it a little bit easier for you guys to see, especially in the back. I'm going to maximize my preview. There we go. Okay. Check it out. The base material is responsible for shading everything. Everything is applied to the base material. Okay? So whenever you initially create any series of new polygons, the base material is responsible for shading that new polygon. Okay? Let me prove it to you. Right now, if you look carefully, everything in our scene is white, right? Is white. Okay? The base material, if we select the material itself over in the shader tree, so I got my material selected. This is the icon for a material. The little green checkered ball, okay? That's a material, okay? And with it selected, its material properties will show up in the right over here. And we want to go to the material reference tab. It often automatically pops up, but I was working on some things earlier and I changed some things, but there it is, material reference. Now we're going to talk about all this here in a minute. We're going to go through each one of these with a very specific amount of detail. But for right now, the diffuse color, if we change that to like red, notice that everything turns red, okay? The base material is responsible for shading everything. You can't turn it off. Well, you can delete it, but you can't turn off its kind of global function, okay? The base material is responsible for shading every single polygon in our entire three-dimensional scene, okay? Any change that we make to the base material is going to have a systemic impact on our entire three-dimensional universe. So if I make it blue, everything in our world is going to go blue, okay? Let's just put it back to white just for the time being. Okay. We're going to be making a whole network of materials here in a minute, but after the computer is done evaluating all of the materials, it goes up vertically one layer. In our case, the next element vertically in our list in the shader tree is the base shader. Now, shaders are really important. They do a number of different things, some of which we're going to explore in this class, most we're not. But I think for today, what I would encourage you to think about is that shaders are going to influence the visibility of all of our objects within the scene. So shaders equals visibility, just for today. They also do some really cool things like allowing us to adjust the quality and how those associated polygons are going to be evaluated by the global illumination system and caustics and some other things. But just for today, just think that visibility, okay? The base shader is going to influence visibility of our polygons within our scene. So for example, if we click on it and cruise over to the properties, look at all these different properties. It's pretty crazy, huh? It's pretty crazy. One of which is visible to camera. So if I turn that off, notice that all the polygons in my scene have disappeared. Now, have I deleted those polygons? No, they're still there, but the base shader is saying, hey, I'm not going to draw you anymore. Okay? So shaders for today, if you kind of keep cruising through a lot of these other things, I'm not going to go through all of these today because they're quite advanced, but you really can see that the shaders play a much larger role when we render our objects. But for today, they're just going to do visibility, okay? So let's turn on visible to camera. There's our scene, rock and roll. Now, once the computer is done evaluating the colors and the surface attributes of all of our objects, it's going to evaluate the visibility. Then it gets to these two things up here. Now, if you look very, very carefully at the icons that are associated with those top two elements, you can kind of get a good idea as to their role inside of the entire Luxology scene, okay? These top two things are classified as render outputs. Render outputs. The icons are these cool little postcards of the Mona Lisa. The render output represents the image that the rendering image is physically going to make, okay? Physically going to make. So when I hit that render button, the computer actually draws two pictures for me. One called final color output and another called alpha output. These render outputs can be changed to export a number of different images from Modo. There's actually a huge long laundry list of different render outputs that we have access to. There they are. These are all the different types of images that we can ask Luxology's render engine to export. Some of these we'll see in class. When you get to 424, you'll be messing around with a lot of these. When you take 410, we'll be messing around with even more of these. The Modo rendering engine is one of the best rendering engines on the face of the planet, in large part due to how we can export and what we can export from the app. Okay, it's pretty cool. It's pretty neat. We'll come back to this a little bit later. To prove what I'm talking about here, I'm just going to tilt down ever so slightly. There we go. And so we have two images that the computer's going to draw. If I hit the render button, check it out. It draws my scene, rock and roll, we know this. At the top of the render window, though, check it out. Here's a pull-down menu of all the render outputs that are available inside of our shader tree. Right now, we're previewing the final color render output. However, and you can see what it looks like. However, if we click on this little pull-down menu, we can also see that the computer is interactively at the same time drawing that other image for us. It's one of the cool things about working inside the rendering engine in Modo is that it's going to draw all of your render outputs at the exact same time. Multipass rendering in Modo is easy. It's really easy, actually, and it's really quite nice. So, okay, I'm going to turn my preview back to final color render output. This is the one that we're going to be leveraging and using for almost 100% of the things that we're going to be talking about in this class. So get used to working with the final color render output. Okay. Now, as I mentioned earlier, the shader tree is going to evaluate from the bottom and work its way north, right? Starting with the base material, it figures out how to draw every single polygon, its surface colors and characteristics. Then it's going to go up one level to evaluate the base shader, and it's going to evaluate the visibility, the quality, a whole bunch of other crazy fun things. And then once it's done with that, the rendering engine is physically going to start drawing images when it hits the render outputs. And it's going to sequentially draw those images in the order that they appear inside the shader tree. So we're working vertically, starting from the bottom and going all the way up here. Now at the top of this is a really important thing to kind of keep in mind. We have the render component itself. If we click on it, the little purple sphere, we have a number of render properties that pop in over here that we need to kind of keep our eye on. This is where we can very easily, as you guys know, go in and change the frame height and width, the frame rate, a number of our camera settings. This is where we get to toggle our global illumination on and off. So these are the global render settings that are going to influence everything inside of our render. Okay? Some of these we'll look at this semester. Others we'll save for more advanced classes in the program. Questions so far? Kind of understanding the method behind the madness. There is kind of a logical order of operations that the computer is going through to evaluate and draw our images. It's not just random. I always like to know precisely how things work. Okay. So I don't have a very interesting scene at the moment. Currently, everything inside of my three-dimensional scene is white. I don't want it to be white. Maybe the only thing that I want to have white in my scene is the ground plane. Everything else, all the other unit primitives, maybe should be a different color. It's really easy to extract polygons from being influenced by the base material in Modo. We've already done this, I think maybe once, just kind of casually. We have to separate, if you will, each of the polygons in our scene from being influenced by the base material. Because the base material, what is the base material going to do? It's going to shade everything, right? It's going to change the color of all the polygons. Well, what if I want to have, like, my little cube there be red? I need to extract it from being influenced by the base material and shade it separately from the rest of the pack. Okay? It's really, really easy to do this, and it kind of follows the big idea that we've been working with over the last couple of weeks with selections. Everything begins and ends with a selection, right? We need to filter our shader tree now. We need to go in and extract certain geometry from our scene and have it be influenced by another element, a new material. So let's select the geometry that we want to initially work with. I'm going to hit the little expand button here, go back down to my OpenGL viewport, and notice that I'm in my polygonal selection set. And I'm going to double click on my cube. So we start with the selection. We've filtered our scene once more with a selection, and now we can perform the command. Does anyone remember what it is to make a new material from this selection? M, you got it. The M key, M as in material. So let's hit the M key real fast and see what we get. We're initially going to get this little popover. It's called polygon set material. And there's a number of values in here that we need to look at specifically. First and foremost, the most important thing is that we have to change the name. We can't let it be default, because if we leave it to default, it's going to be influenced by the base shader or the base material. Boo, we don't want that. That's what we're trying to avoid. We don't want this to be influenced by the base material. So we have to define our own new material. And I'm simply going to call this red. And let's just, if we click on the little color thing here, your OS color picker will pop up. And I'm going to choose the red crayon, because I like my crayons. And then hit OK. Ta-da! Yes, sir.
So when I do that, I normally say like Q. Would it be better to put the name of the color?
There's a number of different ways that you can organize your shader tree. As long as it makes sense to you, and as long as you can decode specifically how the shader tree is influencing the render,
so
I'm good.
Just say if I type in red, and will yours come up? So just say you wanted to do the circle.
Yeah.
If you wanted to make the circle red, could you literally just
Reapply.
Type red and boom, it's on there.
You got it. We're going to come back to that idea here in a minute. Okay. So before we go too much further, let's just kind of decode and break down precisely what the computer has done. Because a lot of people, they start hitting these keys and they don't understand the magic that's going on. Let's figure it out. This isn't mysterious, or I don't want it to be mysterious. We've applied a new material inside of our shader tree, and we've kind of unintelligently have named it red. Let's go over to our shader tree and see precisely what's happened here. Okay. Okay. So if you look at our shader tree now, of course we have the base material whose sole function is to shade everything on our entire scene. But now we have a new material, or specifically, we have something that's called a material group. Little icon, little green sphere, and the little red dot. That's called a material group. Okay. Now in my mind, I think of this just like a folder. It's just a folder in my mind. Okay? Because if we look inside of that folder, then we get access to the element that's truly influencing the surface of our red cube. There it is. A material is always, always, always going to be the driver for how those polygons are rendered in our scene. The group is just a folder. That's all it is. It's a folder that's specifically tied to those polygons. So we've made a relationship between a polygon and a folder. Whatever I do with that folder is going to be influenced by that, or is going to be influencing, excuse me, those associated polygons. Okay. So this just a folder. That's all it is. Yes, ma'am. Hit the M key. And give it a new name and give it a color. What? It didn't change. Did you select your object? Well, you're in vert mode. You got to go in polygon mode. There you go. Now hit M. Give it a name and give it a new color. If you leave it white, it's just going to be the same color as the base material. Yeah. You're going to have to help me out, man. I can't hear a single thing you're saying. What's up?
I put the purple, different colors in the render.
Okay. Okay. So did you?
This one,
Yep.
M.
Now it's got to be different. Can't be default, right? Can't be default. It's got to be something else. It's got to give it a new name. You determine that name. Make it like green, and then make the color green. And remember, I can see people do this as I walk around the class. You have to be in your polygonal selection set in order for this relationship to be created. Okay, click on the material inside that group. No, go back to your shader tree. Does that say plum?
Yeah.
Click on the material in there, in the folder. That's just a folder, right? Click on the material inside of that folder, down one level. There it is. Click on it, click on it, click on it. Don't double click on it. You can close that window. It's just opened up a preview window. There we go. Now it didn't change because you didn't change the color. It's white, the same color as your base material. Okay. So let's keep going here a little bit. Let's keep going. So with our material selected, this kind of serves as an opportunity for us to highlight the relationship between this material and the polygons that it's associated with. These are live relationships. So any change that I make to the color is going to have an immediate impact on the polygons that they're associated with. Check it out. I've selected the material, and now this is such a critical, important piece of terminology. When I say click on the material, I'm not saying click on the thing that says red, okay? Because remember, that's just a folder. That's just a hierarchical element that allows us to organize things, okay? It's just a folder. If I wanted to change it, I got to click on the material itself, okay? The item that's inside of that folder, okay? You can see just by the way the computer is drawing this hierarchy that there's a little relationship here. A little down arrow, and then it pops in, just like the Finder window that we're used to seeing on a Mac. Okay, it's identical. So with the material selected, I can go over to the Properties channel and change the diffuse color value. And if I change it to like blue, you can see immediately that the polygons that are associated with that material group are updated to adopt that new color. Let's do it again. Let's add another material into our scene. Okay. So help me out. I want to make my cylinder in the background yellow. Walk me through the process. Yeah. I like it. So ensure that you're in the polygonal selection mode. And I'm going to click on it real fast. There we go. Bam. There it is. And then I'm going to double click on my cylinder. And then Tyler, what is it? M. M for material. And let's just call this yellow. And I'm going to change the color. Or excuse me, it's the lemon. It's not yellow, it's lemon. And then boom, now it's yellow. Okay? So we're extracting these polygons away from being influenced by the role of the base material. Hitting the M key is a lot like making a mask. In the early days of Modo, they actually referred to it as a material mask. Now it's a material group, but fundamentally we're doing the exact same thing. All right, let's keep cruising. Now what we're doing here is that we're making connections between polygons. You'll only ever be able to do this when you're in your polygonal selection mode. You can't do this with vertices, you can't do this with edges, okay? You have to be in the polygonal component mode to get this connection to be created. So with that said, let's do another one. Let's do the sphere down here. I'll hit the M key and I'll make this green. And I'll make it green or spring, excuse me. Ta-da! All right. Now, I have 3 different materials chilling in my shader tree. And as I mentioned before, this is a polygonal based system. Can I recycle? Yes, sir.
Do you have to go back and redo all this again, or do you just...
For what? Help me out. Give me more context.
Because then, you know how you change the other one to another color? Do you have to redo what you did with the first color? Or you, when it clicked on it, press M and renamed it and did the color? Or can you do that the easier way?
No. If you're trying to apply a material to polygons, you got to select it, hit M.
Okay.
It's the only way to do it.
Okay.
Yeah. Okay, what did you name the material? You made the critical error and you didn't give it a name, okay? But leaving it at default, you're not going to do anything, okay? You got to give it a name. Yeah.
I'm having some problems submitting the thing.
Awesome. Not even what we're talking about. Great.
Well, yeah, sorry.
Okay, zip it up. Archive it.
It won't go.
Okay.
I mean, it's LXO, right?
Yeah,
It
can
won't
you,
even open it now for some reason either.
oops, your file cannot be uploaded. Okay, hit cancel for me. Go into the Finder and right-click on that file and hit compress. Make it a zipped archive and then try it again. Okay. Yeah. Whoa, that's kind of fun, isn't it?
Yeah.
What did you do here? Ah, you're changing your diffuse color to black. That's kind of fun. Yeah, okay. So I wouldn't change your diffuse color to black initially. Oh,
Yeah. I came
Well,
in
hello.
here, and when I went to change that to red, it showed that it was red, but when I clicked it, it was black because. I think
Let's
it's
try
the
this.
transparency of it.
why are you not getting the color wheel, you know? That's interesting. That's really interesting. Let's do this. I want you to save your scene, okay? And then once you save it, go down to the bottom right there and choose Reset.
Okay.
Yeah. I'm sorry, what?
How do I get rid of the box?
Try right-clicking and dragging someplace else. There you go. And Fred, if that doesn't fix it, go to a different machine. And don't let me forget that that is a problem on that machine, because I think I got to reinstall the config if that doesn't work. What? Yeah.
So pretty much like this.
Yeah. Good, good. Okay. So remember what we're doing here is that we're making relationships between materials and polygons. Can I recycle these materials? What if I want my cone to be red? You can redo it, absolutely. We don't have to create a new material for the polygons that are associated with the cone. We just have to reapply the red material to those polygons. Check it out. So I'm going to go in and I'm going to select all the polygons on my cone over here. Just double click, hit the M key, and I'm not going to make a new one. Notice that there's a little pull down menu. If we click on it, it's going to expose all the materials that are currently in my shader tree. The only one that I don't want you to really look at and use is the default, which is the base material. No, 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 don't do that, okay? I'm going to choose, I think my cube's red. So if I choose the red material from this pull down menu, there we go, check it out. I hit OK, boom, now my cone's red. Any change that I make to that red material in my shader tree is going to influence all of the polygons that are associated with that material. Check it out. Let me go to my red material in my shader tree. For me, it's just tilling down here. And if I click on it, let's make it blue. Everything that's associated with that material group has been updated. So we're making a relationship between polygons here. Get it out of your mind that you're making a relationship between objects or shapes within your scene. You're not. We're doing this at a component level. We're doing this at the polygonal level, not like a sphere level or, you know, a box level. We're doing it at the most basic building block. Yeah. So I selected the polygons for my cone, hit M, and then I chose an existing material from the list. Hit M, gotta hit M. Now you're changing the name of things. Yeah. Gotta start with selection. So make that one like yellow. No, don't make a new name. Click on the arrow, the pull down menu arrow. Select it like yellow. Hit OK. See, now it's being influenced by the yellow material. All right, let's do this. I want to hit undo just for a second to get my guys back to red. And I'm going to create a new material for my cone, and I'm going to call it blue. Just so I have all the major primary colors kind of covered here. There we go. Awesome. Huh? Forgot orange? Well, you're more than welcome to do orange on yours. All right. Now, can we mix and match materials on one object? Yeah, absolutely. Since we're doing it at the polygonal level, we can absolutely go in and define how the computer is shading each polygon separately. Maybe I want like racing stripes on my sphere. Maybe I want like every other polygonal loop on my sphere to be an alternating color, like, I don't know, green and blue, or green and red, or green. Let's make a new one. Let's make a new one called purple. Check it out. On my sphere, I'm just going to grab loops. I'll select the first couple in this row, hit the L key. Check it out. Now I can go in, select a couple different rows, hit the M key. We'll call this one purple. We'll make the color purple, magenta. We'll go with that. There we go. So we can mix and match materials on a given object. Now, can one polygon be influenced by two different materials? Yeah. No. No, it can't. You're gonna only be each polygon is only influenced by one material. Okay. Let's case in point. I'm gonna go back to maybe the top row of my purple band here on my sphere. Check it out. So if I grab that row and hit M and choose yellow from my list, boom, it's no longer purple. Now it's yellow. Okay. So polygons can only be influenced by one material inside of our scene. Once we extract them from being influenced by the base shader, they're only ever influenced by one thing. Huh? I just made a selection, so there's a bazillion ways. I hit the L key. I selected a couple polygons on that row and hit L. Okay. Let's go back in. I want to put that back to being influenced by the purple. And let's give our donut here a color. Let's make it, what color? Anne wanted orange. I'll give her orange. There we go. Or tangerine, excuse me. And there we go. Ta-da! Looking pretty good. Looking pretty good. Let's render our scene. There it is. Masterful, right? Give me the Academy Award for Best Computer Animation today. It's a work of art. It's a work of art. No, it's not a work of art. It's horrible. Okay. But we're making small steps into the world of materials and textures. Okay. Questions before we keep going? All right. So let's visit for a second precisely what the rendering engine is doing to establish the colors and the surface characteristics of all the objects that we have in our scene. As 3D modelers and render artists, we have to be extraordinarily observant. We have to look around our environment and understand kind of at a component level how the light is interacting with all the objects that we're seeing in this room. If you just take a look around this classroom, you can see that the light coming from the projector, coming through the windows, coming from the mobile devices that you have in your hands are influencing how our eyes are perceiving the surface characteristics of everything in this room. The wood along our trim looks very, very different from the shiny metallic surfaces of our computer screens or the mice in our keyboard. The floor looks different, both color and by its reflectivity, than the computer chairs that you're sitting on. The light is going to interact with things very, very differently. The material reference section of our materials are going to allow us to help craft how the light is going to interact with the surface of our object. Let's take a look. So let's go through channels, and I'm going to do this on, we're going to start with my sphere, and I apologize, I'm going to step backward just one step. I want to turn my sphere, I want to apply everything on my sphere to the red material. Yep, I think that'll be good. And everything on the cube is going to be influenced by the green. Now I'm doing that specifically because it's really, really easy to see a number of the different the number of different surface characteristics that we're going to change on the sphere in conjunction with the cube. All right, so let's take a look at our surface characteristics, all these different parameters. Now, here's a power user trick, and this is something that I wish someone would have shown me when I was in your shoes. This is one of the reasons why working with Modo is such a joy. We have a pretty intense shader tree over here. We got like maybe half a dozen materials all in our sheet, all in our scene that are influencing a number of different polygonal groups, right? It's getting pretty crazy. I want to very quickly go in and just manipulate and just change the red material, okay? Or the material that's responsible for drawing the sphere, okay? I am horrible, and you probably have noticed this already, I am horrible at consuming long lists. My brain just has a problem decoding that. It's not easy for my little pea brain to do that. So working inside of this shader tree environment at times can be quite a challenge. Well, there's a really cool trick inside the preview window that I need to show you guys. This changed my workflow the moment that someone showed me this. The preview window is actually really quite advanced. This area up in here allows us to work quickly and navigate to the materials that are influencing certain polygons based on what we click. Now, earlier, I was navigating around inside the preview window and interactively changing the location of my render camera, right? Using our traditional viewport navigation controls, we can do that. Those viewport navigation controls are primarily left-click functions. However, check it out. If I hover my mouse cursor on the sphere and right-click, you get a little HUD. You get a little popover right at the location of your cursor. What's happened in this moment is that the computer has fired off a ray into our three-dimensional viewport at the exact same XY location of our cursor. Any material that's being captured by this ray is sending back all of its shader tree information to this little popover. And specifically, we can see all the elements that are directly influencing that pixel. Okay? Pretty cool, right? And you can see almost instantly here from our list. Let me zoom in so y'all in the back can see it. Check it out. Here's our render outputs, our base shader, and then specifically, our material. Okay? There it is. Well, the awesomeness extends a little bit and continues. If we were to click on that material, what do you think is going to happen over in our shader tree? It's going to pop up in the shader tree. Boom, it's automatically going to select it. Even more so, let's do it again. Let's do it on the blue cone. Right-click. Previously on the red cube, I clicked on the material group, and that's what was selected over in my shader tree. Well, what do you think is going to happen when I click on the material? Yeah, let's do it. It's actually going to grab the material now. So I want to take this one. Boom, and it automatically selects it for me in the shader tree. Very, very fast and efficient way of editing existing materials inside of our three-dimensional scene. You let the computer select things for you, and having to try to figure out this crazy long list.
So just for example, like our end projects, including if you want to do multiple duplications, if you do that trick, can you influence everything that has a
Yeah, absolutely.
So if I had like multiple like soldiers with like a gray torso, I could just select the gray and boom.
It'll update across the entire scene. Yeah, it's a pretty cool system. So what we're trying to do here is just make it easier for us to select existing materials and edit them. Okay? By right-clicking in the preview window on any shape. Check it out. I'm going to right-click on my yellow cylinder here, right? You're going to get a little popover. And this popover is going to tell you which elements inside your shader tree are influencing the yellow cylinder, right? Now I'm looking for a material group. I see one in that list called yellow, right? Well, if I click on it, it's automatically going to select that for me over in the shader tree. Boop. So, and it's automatically selected over here. Now I can just go in and make the edit pretty quickly. Okay? It's just a way for us to very, very fast and easily get to the element that we need to change without having, because there are shader trees. I mean, I do this all the time. I'll have a shader tree of a couple hundred different materials. You know, trying to scan that list and find the one that you need to fix is next to impossible sometimes.
Probably takes like 30 minutes just to select that one.
Yeah, I mean, it can be an issue. So this is a cool trick.
I was wondering,
Yeah.
what happens if like you miss, just say for the boat you were in, just say you wanted to make the steering wheel and everything was gray, but you wanted to change specifically the steering wheel and something else. Would you do the same method, or would you have to go individually and pick the steering wheel?
There are some additional methods that will probably give us a little bit more control. Absolutely. We have, you know, we're working at the polygonal level now, where we're making an association between a material and a polygon. You can also make associations between an item and a material, and that's how I often work. I love working with items. Item masks, as they're called here in the shader tree. We're going to get to that in the future. We're not quite there yet, but yeah, there are other ways of changing the hierarchy and the influence of our materials to have different results. It all kind of depends on how you want to deal with it and how your brain wants to organize your scene. Okay. Excuse me. All right. So let's go back to my red material real fast and talk about its properties. And this is where we're going to spend a good majority of our time today, talking about the role of each one of these properties. Okay. This is a daunting area. This is an intimidating area. I know when I was first learning CG and how to do all this stuff, this scared the bejesus out of me. It really did, because there's a whole bunch of letters and numbers, and I was just like, what? I don't get this at all, okay? And I really struggled with it at first. I want to try to make this as consumable as I can and as easy for you guys so there's not that immediate knee-jerk reaction of wanting to run out the door screaming, okay? Because this is an intimidating area. There's a lot of different channels. There's a lot of different values that we need to wrangle. But there are some really important rock stars, all-stars in this list that we need to focus our attention on, okay? We don't need to know everything, but we do need to know the basics. And there are about 4 channels in here that we need to understand. The first one, diffuse color, okay? The diffuse color channel is basically surface color. That's all it is. That's what it can be described as. It's, you know, if you were buying a car, this would be the color that car is. Diffuse color, okay? General color. And then the diffuse amount is just how much of that color is going to be shown on this on the polygon. If we bring that percentage back down to 0, it's going to go closer and closer and closer to black. I very rarely change the diffuse amount. I almost leave it right around between 70 and 80%. That's a good kind of starting point for most things, okay? So think of the diffuse color just as the surface color of that object. Of course, we can go in and change it. Click on it, and then we'll get the really, really fantastic, and this is awesome. I love, love, love the Moto color picker. This is another one of those things that's worth the price of admission, in my opinion. I wish all applications had a color picker like this. It really is the bee's knees, okay? It's awesome because it allows us to work inside of an environment that's very, very comfortable, especially if you're coming from like a print background or if you're used to working with other Adobe applications. This is almost the exact same environment that you're working with, okay? So they give you a lot of different options on how to pick the colors. You can do it on an RGB level. You can do hue, saturation, and value if that's the way you think. If you're an HSV person, you can enter in all your numbers down here. If you're a web person, you probably do a lot of hexadecimal values for your colors. And you can use hex numbers in here, which is like mind-boggling awesome. I think that's great, man. I love it. If you're a photographer and you're used to working in a studio, maybe you want to start judging all of your colors by a light temperature. You know, all light can be measured, and we'll get a Kelvin degree associated with the brightness of that light source, okay? So if you're used to thinking in Kelvin, boom, you can change the colors of your lights or colors of your materials to reflect that right here in the color picker, which is awesome, awesome, awesome. Check this action out. This is one of those things that just kind of blows my mind. Excuse me. I want options. You can change the rules down here. Maybe you want to get all the complementary colors to the one that you've chosen. I mean, now we're kind of going into the traditional artist's wheel right here in the color picker in Modo, and I love that. I think that's fantastic. And now we can find complementary colors to the choices that we've created right here in Modo, which is just fantastic. So I'm in this rules section under the options tab. You can find all the compound colors, and it's all live, just like you're used to seeing in Adobe Cooler. I mean, it's just absolutely fantastic. I love it. Get the shades. I use the shades all the time. I'm a big fan of shades, and these in here, they're just, I just love it. Love it, love it, love it. Really good. For a designer and someone who's using Modo as a design tool, this is an invaluable feature. I love it. Modo's a pretty smart application. It's got a lot of kind of extra things built into the core of it to make it work the way we want it to work. Also, you can save colors in here too. So if you can see that I've already started to save a number of color presets down below. Okay, it's just as easy as dragging the little thumbnail down into the bottom part. Okay, just drag and drop it. Boom, and now I've saved that color. And now I have two that are red. But that's okay. I think you can delete them. Just delete one. Whoops, there it is. Permanently delete. Yep, I want to delete that one file. There we go. Okay. I just drag it down into the preset browser down here. This section where all the other color swatches are. As you can see, I've done that with a number of colors that I constantly go back to, mostly for teaching red, green, blue, white, things like that. Yeah. What's it say? It failed? Bummer. Hit OK. Now, for whatever reason, your asset browser isn't in the color section. Expand it there. Expand the menu. Click on the little gray arrow. There you go. And go find colors. And now drag and drop. Interesting. That's weird that it's not working. I don't know. Okay, let's keep cruising. All right. Okay. So diffuse color. Diffuse color, just surface color. That's all this is, and that's all it will ever be. When we start getting into more advanced shading and rendering towards the end of the semester, we'll come back in and look at diffuse amount and diffuse roughness with a little bit more granularity and understand their impact on how our objects are being drawn in the scene. Okay. Let's go talk about the specular color and the specular amount. These in here. These are actually really important for us to understand and realize. Now, I want to go back over to my preview window and just zoom in on my sphere. There it is. Ta-da! Okay. In the center of the sphere, you see the specular highlight. Help me out. What is the specular highlight?
I think there's a little dot right there.
Little dot. What color is the dot, Rayu?
White.
White. Little white dots. That's the specular highlight. Now, the specular highlight, in my opinion, is one of the most important elements for us as artists to really focus our attention on. If you think about this, what we're establishing here is the reflection of the light source within our scene, right? Our scene is being illuminated by a directional light, which is kind of like the sun. So it makes sense that we have a little bit of a reflection of that light source. Everything has a little bit of a specular highlight on it. Objects that are incredibly glossy have more or less of a specular highlight. More, right? As we see a very sharp, distinct reflection of the light sources within the scene compared to that of something like chalk. Do you see much of a specular highlight on chalk? No, right. The fall off is much, much slower on chalk, so the light hangs out on the surface before it reflects back into the scene. The specular amount controls the intensity of that little white dot in the center of our sphere. Okay? So if I was to increase the specular amount, watch what happens to my render. Let's just do it real fast. Specular amount, the default's at 20. Let's just overdrive it to like 60. Boom, and you can see that that specular highlight gets really, really intense. It's much brighter, and it's much darker on the interior. Yes, sir?
We're messing with this Fresnel thing and trying to work out what that is.
Yeah, we'll come back to that in about 15 minutes. Okay. We're going to hang out in the specular highlight for a minute. So the specular amount is going to determine the intensity of the reflection of our light source. Is it really a reflection, though? No. It's a camera trick. It's a fake reflection. It's not actually a reflection of the light source within the scene. This idea actually goes back to the early 90s. The computer scientists at all the major companies were trying to figure out how they were going to achieve a specular highlight. It's something that naturally occurs on every material, so we needed to see that here in the computer. But they really didn't have the computer programming mastery nor the computer power to generate a true reflection of the highlight, a true reflection of the light source, excuse me. So what they came up with was a camera trick. It's a camera trick. That's all it is. It's a fake. It's not a true reflection. It's just a fake. Okay? Yeah.
So, but the true, the true meaning of it is for the shadow. So you can overcast the shadow behind it, or would it be for the light specifically?
It's for the light. It has nothing to do with the shadow. Nothing to do with the shadow. It's unhooked from the shadow. Well, we have to suggest where the light is within the scene, right? Yeah. Yeah, our human subconscious is programmed to see these little light sources on everything. It reminds us of the relative direction of the sun, the lights in the scene, the light on your desk. It reminds us as to the spatial location of that object in relationship to, in our case, a sphere.
I was just going to say, I remember up until about 2001, lots of games, most games, in fact, just had the specularity was just, it wasn't even there. It was
Yeah.
just like a mark on the texture.
Yeah, that's how they faked it in games, is that it was just physically in the texture. The computer wasn't evaluating a true ray trace reflection or specular light source. So this is just a trick. It's an old school trick. This is one of the original kind of illusions that the computer scientists crafted in the late 80s and early 90s. Now there's a couple. We want to continue using this. This is actually still a very powerful part of our workflow. Even though we can craft and create true reflections of our light sources, this is fast to render. This is extraordinarily fast to render. So it's a cheap, easy illusion that kind of suspends disbelief a whole lot faster than an accurate thing. Okay, I think you're going to find in everything computer graphics, the more accurate your object is, the more expensive and longer it takes to render. Okay, we can do photorealism. Okay, I saw an amazing tech demo over the weekend of some skin shading stuff being done in Lightwave that is photoreal. I mean, for every sense, it's photoreal, but the render time to get there was immense. Okay, this is a fast, cheap way of getting something that's really kind of close. For most things, it's close enough. Okay, the specular highlight in every sense. Well, it does two things. I mentioned the first one earlier. It reminds us of the location of the light source within the scene. This is important, okay? This is important. And it also suggests the surface characteristics of this little sphere. Now, if you think about it, surface characteristic, this is usually where the train derails for a lot of people because you guys aren't used to thinking of your world through surfaces, right? You see shapes all the time, but you don't see surface characteristics. And what I'm talking about specifically is how fast the light is going to bounce off of that object. Okay? Think about it. You're sitting in front of a computer screen that has a very, very reflective surface on it. The light ray coming from a number of different places is going to hit the glass and bounce off almost immediately. You get a very crisp reflection and a very intense reflection at times across the glass, right? Now, if you look across your stations here and look at the backs of all of the iMacs, not as reflective, right? Still reflective, okay? But you don't see a mirror-like reflection of your face in the computer in front of you, right? You see kind of a really blurry one, and it's really kind of soft and very subtle. The surface characteristics of aluminum is very different from glass. Then you take it one step further. Shoot, our walls here, almost non-reflective, right? Almost non-reflective. They are reflective. Everything in our world is reflective, just in varying degrees. Shoot, even human skin is reflective. How do I know human skin is reflective? Because we can see it, and specifically, I can see the lights shining off of your faces in here, okay? Everything in our world is reflective. And everything interprets and kind of absorbs the light a little bit differently. The specular highlight is our opportunity to start establishing that foundation of how the light is going to be interfacing with our surface, or how the illusion is created. Question?
Wouldn't an object that's 100% black not have reflection?
Not necessarily. What about a black pool ball? Or a tire? Or the black plastic on these chairs down here? There's a little bit more that goes into it. A little bit more. So by changing some of the values of our specular highlight, we can suggest different types of materials, right? If the light ray bounces off a surface really quickly, like it does with metal, the specular highlight should be a little bit tighter. If we're trying to create the illusion of a real matte object that's like plastic or the backs of our iMacs, the light's going to interface with that surface a little bit differently, so the specular highlight needs to be very big. We get to control the size of our specular highlight through the roughness channel, which is a couple channels down. Check it out. So we were just working with Fresnel, our specular amount. If we go down to roughness, this is going to determine the size of our specular highlight, okay? So in essence, what we're trying to capture here is the roughness of the surface of the sphere. If our object was very, very smooth, right? Would it be rough?
No.
No. If our object's smooth, it wouldn't be rough. Can you describe to me some objects in our universe that are very, very smooth? Marble, glass, metal, gold, very, very smooth objects. The light ray is just going to bounce right off that scene, so the specular highlight should look a little bit different. Check it out. If I put this down to like 0, watch what happens to this guy right here. Let's put it down to 0. Bink. Just almost like a little pinprick, right? The light ray is hitting the surface and then bouncing off almost immediately. Okay, yeah.
For like bigger scenes in Moto, can that represent the sun also?
It is representing the sun in this particular, yeah. In this particular situation, we have a directional light within our scene, which is the sun, basically. Yeah.
It's just, I see it because like even though you put it to 0, there's still a shading in the back of it. When I'm thinking of sun, you know, you literally can change like the shading completely around it. But that looks like more the light, like you were saying. Like
Yes.
the light of it.
Yeah. Yeah, this is just, remember, specular highlight, the only thing we're determining here is the sun, is the light source within our scene. The light source within our scene. That's really what we're establishing here. By increasing the roughness amount, we're going to create a specular highlight that's a whole lot bigger. If I was trying to do like chalk, for example, or human skin, it's still going to be reflecting the light source, but it's going to have a much different look to it. It's going to be very, very big. The edges are going to be slightly feathered. If we pair a larger reflective, a larger roughness value with a lower specular amount, like 10%, now we're starting to simulate something that has a much, much slower fall off. Okay? The light rays are kind of dancing around on the surface of our object before they're reflected back out into the scene. Whenever we're adjusting the specular highlight, it's always kind of this little dance between the intensity of our specular highlight, which is the specular amount, and then the roughness. They're usually kind of opposites. If you have the roughness value up very, very high, you get a much larger specular highlight, lower the specular amount. If it's a very low roughness, like something that we'd used when simulating a metal, then the specular amount is going to go up. It's kind of opposite. It's a relationship. I think I saw a hand. Yeah.
So, if you're trying to make something seem like it was glowing, you want to use like
Not this at all.
what?
If you're trying to make something look like it's glowing,
Yeah.
yeah, not.
You use like a really low specular and really high roughness, right? And then some other tricks.
I don't think so. For a glow, no. Yeah, now we're talking. We're gonna get to that. We're gonna get to luminosity, and glows aren't something that Moto does very, very well.
Okay, so it just makes the surface look less polished.
Yeah, all we're doing with the specular amount is determining what the surface kind of looks like and how that surface is interacting with the light. Yeah, if that's the way your brain's thinking about it, yeah, absolutely. Yeah, for sure. How shiny the object is. And of course, last but certainly not least in here is the, let's put this back to its original value of 40. There it is. I'll put the specular amount to 20. There's also the specular color, which is something that you can control. Now I have, a green specular color on top of a red surface. Green and red combined is going to equal yellow. So this is an additive color space, as all light is. The Modo rendering engine is a physically based rendering engine. So it's taking the real world effects of how light interacts with surfaces and replicates that here in the scene. Okay? Everything is additive in our world. You take one light, you put another light into the mix, things are going to get brighter, right? Okay. Let's put this back to white. There we go. All right. So let's keep cruising. So we got diffuse color. What's the diffuse color going to do? It's the full color, so it's the surface color of our object, right? What's the role of the specular highlight?
The light shaping, and you could increase, decrease, or change the color.
Change the color. What are we kind of simulating with the specular highlight?
Polish, the level of polish.
Level of polish. The surface. This is one of those parameters that starts to define the surface characteristics, and ultimately we're changing how the illusion of the light source being reflected across our surface. Okay, so this is a reflection of the light source, and we're changing the illusion. It's a camera trick. That's all it really is. It's not an actual reflection. If we wanted to calculate real reflections, let's enter this section down in here. Reflection amount. This is going to determine the reflectivity of the object that's associated with this material. As you can see, it's at a value of 0%, so our object's not reflective. As one might imagine, increasing this percentage is going to make it more and more mirror-like. Let's just put it up to a value of like, oh, I don't know, 80. Boom. Pretty cool. Now it's more like a chrome sphere inside of our object, inside of our scene, excuse me. Yeah, there we go. Yours didn't do that. Why not? Ah, actually it did do that. Yeah, it's reflective. It's reflecting the scene, right? Yeah. And this actually brings up a really good point. Look at the reflections that are being cast inside of my sphere now. What is being reflected across the surface of my sphere?
Everything that would be in front and around it.
Yeah, everything that's in front of around it. So what we're seeing kind of in the middle of our sphere is the environment that this object is chilling within, right? Think of your environment kind of like a beach ball, right? Well, we're not on the outside of our beach ball. We're in the center of the beach ball. We're looking inside the interior of our beach ball right now. And whatever's on the inside of our beach ball is going to show up in any reflection that we have. Okay, pretty cool. It's also reflecting the objects in the scene. Check it out. If you look very carefully on the left-hand side of my sphere, what do you see in the reflections? Yeah, the orange donut. We see a little bit of the cylinder popping over there. On the rightmost side, we're seeing a little bit of a reflection of the cone. So we're starting to get real ray-traced reflections of all of the objects within our scene. Okay? The higher this reflection amount goes, the more chrome-like your object is going to be. However, does it still look a little red to you? Looks a little red, right? Looks a little red. This is an illustration of how all of the channels of our materials are working in harmony together. Sometimes we have to be kind of like chefs in the kitchen, where you have all these crazy recipes to make, a really phenomenal dish. If I wanted my sphere to look more chrome, well, chrome is almost the absence of color, of a surface color. So, yeah, with dark gray tones. So if I removed the diffuse amount to like 0, Interesting. Now we're no longer having the surface color of our object, the diffuse amount, influence the reflectivity, and now we're getting true, accurate reflections of the entirety of our scene. Interesting. Interesting. Usually when you're working with the reflection amount, the higher the reflection amount, the lower the diffuse amount. Now you can mix and match these to taste to get a number of different illusions, but there's a relationship here yet again. Yeah?
What if you wanted to make kind of dark on and just make like a 50% gray instead of white, or use less, more diffuse and use like...
Yeah, experiment around with it, see what you get. For sure, I think you're on the right track. Absolutely. Okay. A couple other things about working with reflections. If you look at the options that are in this section of the shader tree, there are some really interesting things in here. Of course, you get to change what's reflected. Right now, we're reflecting everything in our scene. However, we could go in and say, hey, why don't you just reflect the environment only and ignore all the other pieces of geometry? There you go. Interesting. Our environment's kind of this gray sphere. It's a gradient, actually. The default environment goes from a light gray at the top and a dark gray at the bottom, so now this is what we're getting. Interesting, nonetheless. Not exactly what I want, but I very rarely turn this to environment only, but you can. Let's just go back to full. Now the one that I want to spend some time talking about is this next guy. And of course you can change your reflection color too. This is really great for tinting. If you look at a lot of anodized metals, like iPods for example, the anodized process or the anodization, I don't remember what the word is. However, the process of getting anodized aluminum is special, and it starts to tint the reflections on a much different kind of look than normal reflections do, right? So you can go in and tint your reflections by changing the reflection color. So that's available to you as well. The Modo rendering engine is pretty rad. It allows us to do some really, really neat things. Okay? One of the things it allows us to do is to create blurry reflections. Now, if you look at the back of the IMAX in front of you, aluminum is producing a reflection, right? It's kind of a brushed aluminum look, but it's not real crisp. Look at the reflections on the back. Excuse me, they're not super, super intense, right? You don't really see the precise outlines of the things that it's reflecting. You see a general kind of shape, right? It's all kind of blurry. Human skin, very, very similar to that, okay? It's reflecting things, it's just kind of soft and indistinguishable. We can turn that on by enabling blurry reflections. However, this is a render killer. Okay, let's illustrate this. I want to render my scene with blurry reflections off. Okay, let's just render this real fast. We're off to the races. Looking pretty great. You can see even with reflections on, it cruises through them pretty quickly. And let's see. There we go. 4.5 seconds. 4.5 seconds in its current state. If we turn on blurry reflections, watch what happens across the surface of my object. It's starting to look pretty great, isn't it? Now it's starting to look kind of more like one of those anodized, kind of metals, right? Pretty cool. Yeah?
Just say, if you wanted to, could you put an image in that tall?
Absolutely. Yes, absolutely. Of course. We're going to get to images after the break. Yeah. But now, let's add its defaults. Let's just see how much longer it takes for the computer to calculate the blurry reflections. A little bit longer. A little bit longer. Metallic objects in all rendering engines require a little bit more time and definitely a little bit more love. The previous render took 4.5 seconds. Let's just round that up to 5. Okay? And this one took 15 seconds, so 3 times as long to render out blurry reflections. Okay? And those are just at its low-quality defaults. If we were doing a higher resolution print, you're going to need to increase these values quite significantly to get the butter smooth reflections or the butter smooth blurry reflections that we're after. I don't suggest doing this, but you can go and, well, I don't suggest doing this very often. If it's a very small object within your scene, keep this number low. If it's a larger object in your scene, if, like I have on mine, and we start to see a lot of dots in the reflections, increasing the reflection rays is going to increase the quality of our blurry reflections. Let's just put this up to 128. I'll double the number. Hit the render button and see what we get. It's going to take a little bit longer. There's going to be an exponential increase in the render time associated with the blurry reflection rays. Looks pretty good, though. Looks pretty good. Looks really good, actually. And now it popped out at 21.4 seconds. So definitely, 6 seconds, almost 7 seconds longer than the previous render with those increased blurry reflection rays. So I say keep that off. For metallic objects, you'll need to keep it on from time to time. But keep it off as much as you can. You'll find that your renders will become a little bit more manageable. The problems that folks run into when they start rendering their assignments is that everything has blurry reflections on it. Okay, I think next week we're going to do some metallic objects, and the week after that we're going to be doing glass. And some people they put blurry reflections on a glass object, and now it just takes forever to render a frame. It's not uncommon for the rendering engine to take 5 or 6 minutes to render one frame, especially with some of these advanced shading options enabled. So keep that in mind. Okay. I'm going to do something here real fast. I'm going to put my diffuse amount back to 80. So we'll see a little bit of red pop in there. Awesome. And I'm going to put my reflection amount back down to 0. Okay. So now we're kind of back to almost the default settings of this object. I want to spend some time talking about the Fresnel effect. Right below the reflection amount is a channel that says Fresnel. The Fresnel effect is one of the more important channels inside of our shading tree, as it simulates a naturally occurring phenomenon, this guy right here, the Fresnel. The Fresnel effect is something that we can't turn off. Everything has a little bit of Fresnel associated with it. So what in the world is it? Let's explore it. Okay? I always call the Fresnel effect, or I always use the metaphor that my old boss and mentor told me, and it's always stuck with me because it really made sense for me. Okay? Imagine you're like me, and I do a lot of shopping on Amazon because I don't like going to Walmart. I really don't, because there's crazy people everywhere, and I'd much rather have someone deliver it to my door, right? I can do all my shopping in my PJs in the morning instead of having to navigate, the craziness of Walmart. So I love Amazon. I love Amazon. So, let's pretend that I just ordered something from Amazon. The box has arrived. I get a little text message from Amazon. I don't actually get a text message, but it would be neat if I did, to let me know that the UPS driver is coming down my street, right? Standing on the doorway, excited to get my thing in the mail. The UPS truck driver parks right smack dab in front of me, and I mean like right where this pole is in the middle of the room. So pretend there's a gigantic UPS truck right there. Now, while I'm looking dead on at the UPS store, the FedEx truck, I can see perfectly on the exterior of the truck the gigantic FedEx logo, right? And it looks perfect. This is called the glancing angle, when my eyeballs are perfectly perpendicular to the plane that's directly in front of me, the glancing angle. And I can see the logo on the side of the truck just perfectly in all of its glory. Okay? The little dude gets out of his trucks in his dorky little shorts, right? He comes, brings my package, I sign for it, and he jumps back in the trucks, and I give him a very, hey, thanks for my whatever it is, thanks a lot, I really appreciate it. He jumps back in the truck, and he takes off, and as I wave goodbye to him as he goes down the street, the truck changes its angle to my face a little bit, and now on the side of the truck that used to be a perfect logo has turned into a piece of reflective glass. Have you guys seen that? You see it all the time out there in the real world. You change your angle on it, and then all of a sudden, it turns reflective. Awesome. Everything, almost everything has a little bit of a Fresnel effect applied to it. You see it all over the place. It's a naturally occurring phenomenon. The percentage of reflection is absolutely determined by the angle of your face or the camera to that object. Okay? Let's take a look at what this looks like in action. We're going to turn it on here. And I think probably the best way to illustrate the power of the Fresnel is to see it in action on my little cube here. So I've gone to my green material. I'm going to go to my Fresnel effect and turn it up to 100%. Interesting. Interesting. What parts of my object have gone reflective? The top. The areas that are parallel to my eyeballs, right? And as I change my perspective around into the scene, this percentage of reflection is going to change. So as I change it, watch. Change. See how it turned off there? As I look at the top, Now the top isn't reflective, but the sides are. Isn't that crazy? This is the Fresnel effect, okay? And everything has a little bit of a Fresnel associated with it, okay? And it's fantastic. Yes, sir?
There's a lot of Fresnel on glass.
There's a ton of Fresnel on glass, absolutely. Absolutely. You're going down the street in your car as you pass by, some of the office buildings in downtown Sacramento, right? You can, as you get perfectly perpendicular to a pane of glass, you can see through the glass to the miserable office worker on the inside, right? But as your car changes its angle to that glass, then it turns perfectly reflective. That's Fresnel. Yeah.
When you do the Fresnel thing on the shader, does it do the entire render object, or do you have to do a specific?
It's going to influence the polygons that are only associated with that material group. You got it.
Does it not work so well with darker colors?
It depends. It depends. There's a lot that goes into it. Let's see if I can make something that's pretty dark here. Let's put my diffuse color for my box down to something almost black. Yeah, so no, it works. It works. What I would suggest, if you're making darker colors, a lot of people get into the habit of just dumping down their diffuse amount. Don't do this. Don't do this, okay? Change the diffuse color. If you want the color of your car to be black, make the diffuse color black, okay? So it's the Fresnel effect. Select the material that's responsible for shading that cube. No, you had it right. Go back into your preview window. That works too, okay? Now, with the material selected in your shader tree, go grab your material. Yeah, so you've selected it here, but we need to go grab it over there, right? Yeah, click on it. Now, all the properties that we're seeing here are the properties of just that selected material, and we're changing the Fresnel. Yeah. Yeah, it's working. It's on. It's on. Absolutely. Now this gives us some really cool results, especially when we're working with, organic objects, and you definitely see it in objects that have a lot of curves on it. Check it out. Look at my donut. Let's do the exact same thing for my donut. I'm just going to dump up the Fresnel effect quite intensely here. Let's put it to 80. And check it out. The inclusion of the Fresnel effect gives us the smallest indication of reflections around the edges. It almost immediately makes this object feel a little bit more three-dimensional in the render. Yeah?
There's two Fresnel effects. There's one on specular. I'm having a hard time understanding what that one is.
You're not going to see a huge impact when we start messing around with the Fresnel effect on the specular. It's one of those things that's kind of an advanced channel that works in very, very specific situations, especially when you start applying what's called an anastrophic material to your scene. That's crazy advanced, like doing realistic carbon fiber or realistic. Have you guys ever seen some really cool like metal art? Like, I see it all the time. You got a huge piece of metal and someone's taking like an angle grinder and has grinded in like really cool, unique shapes into the metal. And then when you're looking at that piece of metal from one perspective, it looks kind of like greenish red. And then you change your perspective and the color of the reflections is something different. That's an anastrophic material. They're crazy advanced to set up. I don't even think I understand all the moving parts, to be entirely honest, of those anastrophic materials. But those types of materials work in conjunction with the Fresnel channel on the specular highlight. I think I can count on 0 hands and fingers how many times I've changed the Fresnel amount on my specular.
So it's really not necessary.
No, unless you are crazy good and you're doing some really super, and I mean super advanced material and textures, then maybe you'll want to change it. Abel, I would suggest going down by Leland. I think this machine here is on the fritz. Yeah. No offense to you, Ray, or anything, but there was someone yesterday complaining about that machine not working correctly. So I put a little bit of Fresnel on everything. Everything in my world gets a little bit of a Fresnel. And I just love the realism that we're starting to achieve just on our little donut down here. Just the edges are starting to become a little bit more reflective. The interior, the parts of our object that are facing me as the viewer, not reflective at all, but we're getting a little bit of reflection around the edges. Just makes it a little bit more dimensional and certainly looks a whole lot better. Okay, let's go back to my sphere just for a moment. There we go. And the last thing that I want to talk about is the clear coat amount. This is actually a really neat value. What this does is it generates kind of a lacquered finish on the object that we're manipulating. So if you wanted to create the illusion of like a polyurethane kind of seal or a finish, a clear coat finish on your objects, just turning this up to a much higher percentage is going to give you a cool result. Now on the surface, it seems like we're just making our object kind of more glossy. And we kind of are, but it's actually doing a whole lot more underneath the hood than meets the eye, okay? It's looking a little bit more glossy, and just within a couple mouse clicks, we're able to kind of get that lacquered finish look, okay? This is uncoupled and unpaired from the reflectivity values of our objects, okay? So we can control reflections on a couple different levels. Kind of nice. Okay. Questions before we go further? Okay, I want to turn my clear coat amount back down to 0. And I want to show you just something really, really quickly here. I'm not going to go through the process that I'm employing to generate all this stuff, because I just want to show you the technology. Turn this down a little bit. There we go. Okay. Now, one of the things that we have access to here is an effect called bump. Okay? All surfaces are rough. There's little pits and grooves and peaks and valleys across the entirety of our surface to yield the results that we want. Okay? We can control this, and we can create this quite easily inside of Modo using a number of different techniques and a number of different processes. We're going to go through these over the next couple of weeks, but I wanted to just kind of draw focus to the bump amount, or the bump amplitude, and the displacement amount inside of a material, because I get a lot of questions on this. It's like, well, what about all of this stuff down here? What's this bump amplitude and displacement amount? Well, or displacement distance. These are going to control the amount of bumpiness our little guy has. Now I've wrapped the texture on my what am I doing here, Pat? Not that. That needs to go down to 0. Let's make it a little bit reflective. Here we go. All right. And you can see across the surface we're kind of getting the illusion of little bumps now. You can see the peaks and valleys. Well, that bump amplitude determines the distance that all these objects are going to be bumped along. And now I got little valleys, peaks, and all sorts of fun things happening across the surface of my object. There we go. Now it's more bumpy. Yeah, pretty cool, huh? Pretty cool. So the bump amplitude kind of changes the surface relief, and we're going to go over how to make these here, I think next week. But I just wanted to bring to the surface what that channel does. It determines the distance that relief, those peaks and valleys, are going to be created within the surface. Okay. Now, if you look very carefully at what's going on here, I have a little simple bump map applied to my scene, and now we're starting to simulate something very, very different. It's pretty fantastic. But my little sphere, it's still a sphere. A bump map is never really going to change the shape of our object. A bump map is, again, it's kind of a camera trick. It's an old school camera trick. It was created right around the time that the specular highlight was being created to craft an illusion of peaks and valleys, right? But it's not actually changing the shape. It's still a sphere. The computer's going in and drawing fake shadows and fake reflections for us to kind of trick our eye into believing that there's relief and surface characteristics along our object. Don't worry about that. We're gonna talk about how I did the bump next week. I just wanted to illustrate what the bump amplitude does. Okay. Yeah, it's pretty great. The displacement is kind of a little bit different technology, the displacement distance. I mentioned just a moment ago that the bump technology is just a camera trick. It really doesn't change the shape of our sphere. The displacement illusion absolutely is going to change the shape of our sphere and physically push and pull our polygons into new shapes. Let me just kind of illustrate that for you. Yeah, there we go. You can see that my sphere now has grown in size a little bit. The edges are a little bit more jagged, and we're starting to achieve a much different illusion. And FYI, don't judge. This is just a preview of our bump. I know a lot of people, they freak out and they go, oh, is it really going to look that bad? No, it's going to look a whole lot better. We only get a low-quality preview of our displacement in the preview window. The moment that you render it, it looks butter smooth. Unfortunately, displacement effects and bump effects increase the render time that's associated with our scene. But it looks pretty cool. Pretty cool. Pretty rad, huh? Yeah.
This is kind of out there, but why did it take the 3D modeling program so long to render these things that it takes Game Engine a couple seconds to render?
Well, Game Engine can't do this.
Okay, so it can't do it on the same level.
Game Engine can't do displacement like this at all. Does bump. Yeah, it does bump. It does bump. Yeah, different set of technology. Different set of technology. One of the things that we haven't talked about yet is that we're using a global illumination system in here. So we're actually creating a physically based rendering environment that's yielding accurate reflections. We're doing final gather. If I was to turn that off, this is what a game engine would produce. Let me show you. That's the illusion our game engine produces. And if you look carefully, now we're getting just pure darkness in the shadows. Yeah. Yeah, and that's why the global illumination system is so great. It gives us that physical, photorealistic accuracy, but it comes at a cost. It comes at a cost, for sure. Other questions? Okay, let's take a break. Let's take a break. I think I've made your brains melt. So let's take a break. Yeah. What you got? My computer seems to be choosing not to work the way I wish it to work at the moment. Real quickly, I just wanted to kind of show and illustrate the power of the Modo rendering engine in the power of the shader tree. During our break, I made this really quick little example of one of the things that you can do quickly with the stuff that we have available to us in the shader tree. Earlier, right before we went on to break, I did a very quick displacement of that sphere. And by adjusting some of the values and by adding in a gradient, I can change how the computer is choosing to colorize that sphere based on the height of displacement. And now I've created a cool little kind of, I don't know, planet Earth thing. And it's transitioning from the darker colors to the greens and then to the snow-capped mountains up at the top. And it's just an extraordinarily powerful rendering engine that allows us to do some really neat things quickly inside of the app. And I find it extraordinarily entertaining, and I love it. It's just phenomenal. However, I wanted to spend some time today and transition over into the remaining part of our conversation today about textures and materials. For this week's homework assignment, you're going to be jumping in and establishing all the textures and materials for your corkboard. And one of the things that you have to do is to place a whole series of photographs or textures or images on the posters that you've created. So I wanted to go through that process. Yeah?
That's not going to involve UV mapping in this case?
Today it's not going to involve UV mapping.
Okay.
We're going to do what's called projection mapping today. And you'll see the fun that's involved with that. Question? No. All right, let's go ahead and jump in and take a look. Now I'm going to make a new scene file here real fast, just so I can get rid of all this stuff. And get it down to, let me close this, close scene. Nope, don't want to save it. And let me just go back to my model tab, and I'm going to start off the day, or start off the session, just by working with a very cool little cube. As we know from our previous conversation about materials, I get to isolate this from the shader tree by hitting M, and I'm just going to call this material called cube. Leave the color white. There we go. Now let's go jump over into our shader tree. Okay. Now we're going to pretend, and I got to apologize. For whatever reason, my computer's not working the way it needs to, and the illustration that I normally draw upon is refusing to open. So we're going to pretend that this is our corkboard. And we're going to pretend that this is one of the pieces of paper on our corkboard, and we need to get an image onto one of the surfaces here. Okay? It's really easy. Actually, let's just do this. I'm going to have two things. I want to have a cube, and then I'll also have just a single plane in here. Something like that. There we go. Let me just move this kind of in line here, just so we have the two. Okay. All right. Ta-da! There's my simple, dorky little scene. Wow. That is weird. Modo is not letting go of some memory right now. There it is. Now it's updated. Okay. All right. And I think, to be entirely honest with you, everything that I'm experiencing right now is completely associated with my live stream. I'm taxing my little laptop more than I should. I opened up my live stream software a minute ago, and it has a little counter telling me how much CPU usage I'm currently demanding from my machine, and I was at like 97%. So my little computer's cooking right now. Hopefully it doesn't melt. Okay, so this is the scene that we're going to be working with, and I've already started to isolate out these objects, but I didn't do this. I didn't isolate this this two-dimensional plane from the rest of my scene, so I'll just call this one. We'll just call this one poster. Okay. All right. So here's the mission at hand. We need to map some images onto these polygons. Now earlier when we were working with the texturing workflow in Modo, we were just changing the general color of things, right? We never really put a texture on there, okay? So in your minds, I want you to start making a big kind of difference between a material and a texture. A texture can be defined as an image. In some applications, they're referred to as image maps. Here, they're kind of, you see them in both. You see them referred to as texture maps. You also see them referred to as image maps. So they're all kind of the same thing. It's just a JPEG. It's just a photograph that we're going to place on a polygon. Okay? That's it. That's all we're going to do. We're going to put a photograph on a polygon. Now, the rules that we have to employ to get that polygon, or to get that image on that polygon, are a little bit different. And let's just kind of walk through the workflow. Now, I'm going to start with the cube. Okay? Let's just start with the cube. And remember, I have this cube sitting in its own material. And there it is, just chilling right there. So here's what I want you to do. You're going to be doing this 2 or 3 times in your homework assignment this week. And I want to just kind of walk through the process. I need an image. And I want that image to be mapped, to be placed, if you will, on my cube. Okay? So here's what I want you to do. I want you to get into the habit of selecting the material group. It's a folder, right? That material group, the one with the green and the red dot next to it, think of it like a folder. Whatever's on the inside of the folder is going to influence the polygons that are related to that folder. Right now, the polygons that are related to that folder are the polygons that make up our cube. So with that folder selected, our material group, I can go to the top of my shader tree and I can import in some new elements. So if we go to the Add Layer pull-down menu, we're going to get a whole laundry list of options of things that we can add into our shader tree. One section is going to be called Image Map, and it's kind of towards the bottom. So Add Layer, Image Map, excuse me, kind of in the middle. And then you'll see all the options over here. Now, what we want to do is that we want to load in an already existing photograph into Modo. Now, I want you to place some images on the posters that you created. They can be any images that you want, so you can make your posters look however you'd like. Just please make sure all the posters are rated E for everyone, so no explicit content, please. Yeah? I went to the top of the shader tree. On the right-hand side, there's a pull-down menu called Add Layer. Right there, Allison. Add Layer, Image Map. And we're going to load in an image. We're going to load in an image. Let's just load it in real fast. It's going to bring open your standard OS dialog box, and you can see that my computer is wigging out right now. It's really wigging out right now. Okay. So here's I gotta kind of. I have to go through the back door here, and I apologize. Let me see if I can try getting this thing in here. No, it's just really not allowing me to do it. Darn it. Let's try this. I'm going to win one way or another. There we go. Okay. So normally you'd go Add Layer, Image Map, Load Image, but because my Modo is choosing not to like me at the moment, it's not even recognizing the files on my machine because my processor is just being pegged right now. So I kind of had to go in and get it in a new system. But most importantly, we now have that image map chilling in our scene. Now this is a photograph. It's a JPEG. There's nothing fancy about it. It's just an image, a photograph that you'd find on Google, okay? Or something that you could take a picture of with your phone. There's nothing magical about this image. It's just an image, okay? Just a photograph. But what's important now is that it's inside of this hierarchy. It's inside that material. It's part of the shading network, if you will, for the cube material group. Whatever's on the inside of that folder is going to be placed on the polygons that are associated with that folder. If I zoom out and take a look at what's going on with the rest of my scene, you're going to see that my poster is untouched. Look, my poster over here, that long, skinny polygon, it's untouched. Nothing's being influenced because I've separated the shading network in our shader tree to allow me to control the cube polygons separately from the poster polygons by having those two material groups. Now, does it look like it's being mapped onto my polygons correctly? Not really, no. We got some issues in here, and let's talk about precisely what the computer is choosing to do. If you cruise around your scene, if you're following along, and if you're playing along, you're going to see that the computer is kind of using a really interesting series of rules on mapping this object to our scene. This is called projection mapping, where we're taking a flat, two-dimensional image and blasting it, if you will, projecting it onto a three-dimensional object. Now, the best way that I think my brain can kind of wrap its head or my head around this whole idea is imagine that if you're at imagine that you're at the cinema, you're at the movies, right? You're going to go see RoboCop this weekend or the Lego Movie, and you're sitting in the back of the theater, and you're sitting in the theater, and in the very, very back there's a projector, right? A digital projector, and inside that projector, especially if it's an older projector, there's going to be a two-dimensional film negative cruising across a light, and that light is going to shine through the film negative and project that image onto a big screen, right? We're doing kind of the exact same thing. We have a little cinema projector chilling inside of Moto that's invisible, and this image of my toy tractor is being shined through that projector, and it's ending up on the screen of my three-dimensional object. Okay. Now we have to change the rules a little bit to get the illusion that we're after, because it's not really working the way I want. The way my little cinema projector is projecting this image onto my surface is not right. So we got to change the rules. Let's go over to our shader tree and examine the contents of our material group now, because as you can see that we have a new player in that, the toy tractor image itself. Okay, and this is a photograph. There's one important element inside of all images that everyone needs to be aware of, and it's the texture locator. The texture locator in all 3D applications are the one element inside of our scene that's responsible for determining how and where that image is going to be blasted or projected onto our three-dimensional object. So its sole purpose is to place a photograph on a polygon. The rules that are associated with that texture locator determine how it's placed on that polygon. So the texture locator is the most important element for us to work with in kind of resolving the problems that we currently have. So if I click on my toy tractor image, over in my properties panel, you can see that it's brought to the surface a number of properties that will allow us to change the way that our little projector is blasting this image onto our polygons. Now, for me, the one that popped up was texture layers. You can see that vertical tab selected on the right. However, we need to go into the texture locator. Yeah.
I have texture locator, but not texture layers. Oh, clicked on the. Never mind.
Yep. So let's go to texture locator, because as I mentioned a moment ago, the texture locator is the part of this image that determines where and how this image is going to show up on our object. Now, there's a lot of neat things in here, and there's some crazy math going on behind the scene. But initially, what I want to draw your attention towards is the projection type. These are the rules. These are the rules that determine how this texture, this image, is going to be projected onto the surface of our geometry, right? The default is something called UV map. Okay, now we're not at the stage where we can use UV maps yet, so we need to change it. Ultimately, when you get through 424 or even towards the latter half of this course, you'll understand the role and importance of UV maps. They are a critical part of our texturing pipeline, but we're not there yet. Okay? So we need to change this. We need to change this. I need to not use a UV map, and I want to use a different set of rules. Notice that where it says projection type UV map, so right here, it's a little list. It's a pull-down menu. And we have a whole series of options in here that will allow us to change the rules that our little projector is using to map the image to the surface. Let's give it a try. Let's experiment. Now, I like the way Ray Yu is thinking, because what he's doing is like, well, I have a box, right? I have a cube, and I want to put an image on a cube. Maybe if I match my overall object shape to one of these rules, I might get a result that I'm after. Okay? And that's really the idea that you want to approach this with. Analyze the shape that you're after, or that you have, and find one of these rules to match that shape. We have a cube. Let's see what happens when we use the cubic projection type. Now, I'm going to zoom out for a moment just so you can see what my image looks like currently on my cube. There it is. Check it out. And look what happens to my image when I change its projection type to cubic. Hey, a little bit different. Now we're talking, right? What's happened? Yeah, you got it. It's taking that one image, and it's putting that one image on every face of my cube. Rock and roll. Now we're getting closer. Question? No. So the rules that we select under the projection type pull-down menu are going to have a direct influence over how our image is going to show up. Just for giggles, let's change the projection type to spherical and see what we get. Whoa. Doesn't really work, right? Doesn't really work. The spherical image type, or excuse me, the spherical projection type is not giving us the result that we want. And if you look at the render window here, you can see that it's being twisted and distorted and pulled in some really weird areas, and we're not getting what we want. So spherical. One thing that we can also change, and this is kind of dependent on the rule that you have applied, is the projection axis. Think of it, okay, so I have, let's pretend this, my little hand sanitizer is my cube, right? If I'm projecting down a different axis, I'm changing the direction the cinema projector is blasting that image down. So from Z, I'm blasting the image down the front. If I change my projection axis to Y, I'm blasting the image as if the cinema projector was on the ceiling, blasting the image down. And if I was projecting along the x-axis, it's like the projector's on the side wall and projecting it from the left or right.
Was this what we were talking about the sphere eye? Like how you were like, it depends on how you rig it?
A little bit, yeah, a little bit. Okay. A number of these projection types will allow us to change the axis that the cinema projector, metaphorically, will change the image on our object. However, planar gives us a really interesting result. As you can see now, the image isn't, or the computer isn't stamping this object on every single face of my cube. It's only showing up on one. Cool, right? Planar is the one that you guys are going to want to use for all the posters on your corkboard. Planar, okay, planar. But we need to make sure that we're choosing the correct projection axis. Check it out. This is pretty neat. If I change my projection axis to Y, where do you think my little cube is, or my little tractor is going to show up? Along the top. Let's test it. Boom, and you're absolutely right. Okay. Now the location of the texture locator has changed and is projecting that image down as if it was from the ceiling. Okay. If I change my projection axis to X, boom, now it shows up on that side. Okay, which is pretty neat. This is going to be the first challenge that you guys have to overcome, choosing the correct projection axis for your image within the scene. It's all contextual. It's all contextual. Depending on how you've crafted your scene, you are going to have to change this. Yeah?
Yeah, because you switched from solid to planar and it gave you like a mirror image.
Yes. Okay. Yeah. And you designed your scene. Let's see. Orbit your scene around a little bit down there at the bottom. It's facing positive Z at the moment, so, but that's okay because we can always rotate this after the fact. Yeah, so if you're not quite getting the result that you want, check it out. There's more options here that we have at our disposal to continue refining how this image is showing up on our polygon. I'm going to put my projection axis back to Z so that my image is just kind of chilling here on that front face. Okay, now check it out. This is kind of neat. What if it's not angled correctly, or like in Leland's case, his is flipped around 180 degrees? Well, thus enter the role of the transform section of our texture locator. When using these projection types, we can use the general rule, cubic, spherical, cylindrical, planar, to determine the rough placement of this object. But if we need to fine-tune it a little bit, changing the position, rotation, and size parameters inside the transform section will allow us to get the accuracy that we need to place this texture wherever we want. Let's do it real fast. Let's just rotate this thing 90 degrees and see what we get. Let's rotate it 90 degrees along the y-axis. Oops, let's not do that one. Let's do x. Should rotate. Now the texture locator is actually in the center of this thing, but that's okay. Let's see, can I rotate? There, that's what I was trying to do. Rotate it like this. Now, I have an interesting little solution, or an interesting little problem that's popped up here. What's happening along the corners of my cube? Yeah, something's spilling over the edges, right? And it's stretching. We're getting that banding kind of popping back along the z-axis of this cube. Not exactly what I'm after, right? Let's further illustrate this crazy idea that we got going on here. Okay, check it out. So I've changed the rotation value along the z-axis a little bit, and you can see those bandings. What would happen if I was to change the size of this? Interesting, right? Interesting. It's going to spill over the edges. If I make it a little bit smaller. Uh-oh. Uh-oh. Pretty cool. I've made it smaller, and now I have a whole army of toy tractors across the front of my little guy. Interesting challenge, right? Interesting challenge. What we're seeing here is one of the big inherent challenges of working with these projection types, is that they're going to want to repeat that texture over and over and over and over again along the x, y, and z axes. This is something that you'll probably have to adjust as you start to work with the textures going across your posters. However, we can change this. We can change it so that we can isolate these objects from repeating over and over and over again. Now, the ones going back on here, I have questions on whether or not we're going to be able to get rid of all these bandings. But what if we just wanted to have one toy tractor in the center? Well, check it out. Down below, we have the horizontal and vertical repeat. These two channels are going to determine the stamping pattern of this texture across the entire surface. By putting both of these values to reset, there we go, reset, we're basically going to tell the computer to stop. Yeah, look at that. Yeah, we're still getting the banding going that way, but it's no longer wrapping around the outsides, which is kind of cool. If we took the vertical repeat to reset, boom, now we just got one. Yes, sir?
Is there a way to make it where parts of the image are translucent?
There is, yep. Absolutely. Yeah, the Modo rendering engine does support alpha channels and transparency information on textures. I can show you that here in action in a minute. We'll come back to that, Ray. We'll come back to that. Okay. So by toggling the horizontal and vertical repeat to reset, we're basically telling the computer to only stamp one of these textures down on our surface. And now we have what we want. Pretty cool, huh? Pretty cool. One other thing to kind of keep in mind as you work with this, the guys down at Luxology have done us a solid. They've done us a really nice favor here, and they've given us a command called auto size. I like auto size. If you're really confused, if your image is being mapped onto your polygons really oddly, if it's really big, or if you got like a bazillion of them, hit auto size. You never know what you're going to get. The computer's going to analyze the shape that you're trying to map the image onto, and sometimes, yeah, sometimes you get lucky. Sometimes you get lucky. Okay, and now I have just one of my little toy tractors on top of my polygon. Pretty cool, huh? Pretty cool. So planar projection type. That's the one that you want. Okay. So Ray, you had a really interesting question, and I want to kind of answer that question for him. Okay. I'm going to put that exact same toy tractor on this feller over here. Okay. If you look carefully at my toy tractor, it actually has a transparent background, okay? All of this in here is transparent, so it's just kind of hanging out by itself. I want to go into my poster, do add layer, image map. This time, since the image is already imported into my system, I can use Clip Browser and just select it from the list. Now let's change. Now it's not being mapped correctly. How do I change my image to be mapped correctly onto my poster? Where do I have to go? Texture locator, texture locator, texture locator, texture locator, okay? That's the one element inside of Modo that's responsible for placing the image on a polygon. Where do I find the texture locator? Where can I go to get it? Top of the Properties tab. So make sure that your texture is selected in your shader tree. I have mine selected right here. And then the top of the Properties tab, there's the vertical tab called Texture Locator. where do I go to change the rule that determines the projection of this image onto the polygon? Projection what? Let's change the rule. Projection type, absolutely. And this is something you will have to change because the default is UV map, which is not what we want, okay? So let's go from projection type. Which one do you want to use for your posters? Which one? I heard it. Planar. You got it. Planar. And then you have to choose the projection axis that you need. Now, you can see that I have some issues here, right? I see two repeats of my image, and it's not exactly centered. What do I have to do next?
When I did that, my image totally disappeared off the object.
This may solve your problem. What do we got to do next?
Reset horizontal and vertical repeat.
You got it. Turn off the horizontal and vertical repeat, and then choose auto size. So let's go down to horizontal and vertical repeat. Let's do auto size first. Sometimes you get lucky. Yeah, that didn't work. So let's hit undo. Let's turn off the horizontal and vertical repeat. There we go. And it's gone. It's absolutely has disappeared now. That's a little bit of a problem, isn't it? I want you to look very closely in my OpenGL viewport down at the bottom of the screen. You can see both the cube and the poster, right? Where is the cube located within our three-dimensional scene? Look closely. Where is the cube located? At the origin, right? Randall, what tells you that it's at the origin? The work plane? Yep. Yeah, absolutely. And specifically, the black lines, right? At the intersection of those two black lines of the grid, the origin. All unit primitives and all shapes are going to be placed at the origin of the scene, right? As are all texture locators, okay? The texture locator needs to be in the same place as the object that you want the image to go on, okay? Look carefully at the origin. I'll zoom in so you guys can see it a little bit more easily, but check it out. You see these little white lines? Those are the texture locators, okay? That's the visual representation of the texture locators within the scene, okay? So what we need to do here is that we need to move that little box to where my polygon is, okay? Now you could absolutely go ahead and do this numerically through the transform section over here. So I got my texture locator selected, so I can change the position values and physically change the location of my object within the scene. Yeah, there it is. Now it's moving. You see it? Oop, it moved it too far. Yeah. Can you see it moving? That little white cube? That's the texture locator. And as I continue to move it left and right, I can kind of zero it in. Maybe move it up a little bit. Yeah. Awesome. And now we're getting there. So that totally works. Okay. I need to scale it down some so I can go into the size section of my texture locator. And here's a great little trick. If you want all three of these values to be changed simultaneously, hit the little gray 0 at the right of those channel input boxes. If you click on this, boom. Now anything that you change here will automatically be applied to the channels below. And I'm just going to make this a little bit smaller. Ta-da! I'll move it up. Now I got my image where I want it to go. Pretty cool. Pretty cool. A couple weeks ago, we talked about the hierarchy between items and components inside of Modo, right? What are the 3 component types inside of Modo? Pop quiz. What are the 3 components? Yeah.
Polygons, vertices, and edges.
Bingo! James gets the gold star for the day. Absolutely. Polygons, edges, and vertices. Those are the 3 component types inside of Modo. And then we have items, right? Items are the parent of a mesh, right? There are many different types of items. We talked about the role of the mesh item, I think the last time we talked. We saw this in action in a couple different places. Well, texture locators are actually classified as items, okay? They are the parent to the texture itself. They're responsible for placing things. This is a cool power user trick, and I wish someone would have shown me this when I was in y'all's shoes. If you change your selection system to items, so at the top of the screen, so you got vertices, edges, polygons. We can actually select things by materials, and then we can select items. Check it out. I can actually go into my OpenGL viewport and select the texture locator item. With just that white outline selected, check it out. I can activate my Move tool and interactively change the location of that texture anywhere where I want to go, which is very, very cool. You can even grab the Scale tool, scale that texture locator up and down, and place it much, much quickly inside of my scene. Something like that. Interactive texture placement with the texture locator. Yeah?
What if you wanted to center it exactly in the center?
That requires a little bit more engineering, but it is possible. I think for today, I don't want to overwhelm you guys, just eyeball it. But there is a way to get Modo to understand the center point of polygons within our scene. All right, this is looking pretty cool. I like this a lot. Now, I'm going to answer Ray Yu's question here. He asked, can I use an image with transparency? This is really kind of neat. Modo understands transparency at a fundamental level. It's part of the core architecture. What if I wanted to have a poster that maybe this is a sticker. Maybe this is a tractor-shaped sticker. That's what I want it to be. Okay, I don't want it to be a rectangle. I want it to be a sticker that perfectly matches the outside of my little tractor. Believe it or not, that's very doable. That's easily doable here in Modo. Okay, it's pretty great, actually. There's no way in the world I'm going to go in and model the outline of that tractor. There's too many individual curves. It's compound. I mean, I could do it, but it would just take me some time. Watch this. This is cool. This is cool. Okay. With my image selected, I'm going to go back down to my shader tree and change its effect. So here's my toy tractor. We haven't talked about this column yet for a lot of different reasons. That column determines how each one of these images is going to influence the larger shading network of our scene. The default value is diffuse color. So right now, it's just influencing the surface color of our object. If I change my effect, however, I can have some really cool things happen. I'm going to right-click on it. And I got to remember what channel it's in. I think it's under... Now, they moved it on me. Special effects, yeah. Check it out. I'm going to go under the special effects category and choose RGBA. A means alpha, which is a fancy word for transparency. So now we're going to access the transparency information that's embedded on this image and apply that to our polygon. Boonk. Pretty cool, huh? Pretty good, pretty cool. Now, this is not something that's seen in the OpenGL viewport. You only see it in the render window, which is why nothing's changed in OpenGL. This is a render feature only. But now we've made a polygon, because that's still surface, a polygon that precisely matches the shape of our tractor. Yeah?
So I was just going to point out that you can also edit the materials under these things so that like it'll have, if you wanted to say a poster, you have that Fresnel, it'll
Yeah, we're still...
shimmer like a poster.
You got it. You got it. Absolutely. And I think James brings up a very, very good point here. You know, these are still polygons that are being influenced by the lights in our scenes. Okay, so I could go into the material here, and let's just increase. I'll do clear coat. Let's put it up to 100. Now, in this particular demo, it may not be giving me the result that I want, but that material is still in play. You know, it's still a factor in everything that we're doing. Here's my cube. Let's go down to this one. I think I can even change the color of my cube still. Yeah. Can change the reflectivity of this. Yeah, pretty great. Yeah, so it's now part of the larger shading, you know, kind of system. It's not static by itself.
This might be out of the ballpark, but when you had it so low, could you turn it into a 3D image?
Kinda. Yeah, we're not going to get into that today. That requires a little bit of engineering, but not impossible. You can do it. Yeah, I think we're just going to end it as kinda. You can kinda do that.
Is there any way to go into a material and then reset which polygons are used for it?
Go into a material and reset which polygons are associated with it. No. Yeah. You'd have to, well, I think, so let's take a step back and look at the larger question at hand. What are you trying to accomplish? What are you trying to do?
I've got an image, right?
Uh-huh.
And around its edges, it's transparent, but there's other textures that I want underneath it to show through. So I was thinking about selecting that area and turning it into a material, but then that material overrides the other one.
Yep, because polygons can be only influenced by one material, right? Yeah. Yep. Interesting challenge, isn't it? Yeah, you have to be kind of a mad scientist at times when you start getting into the advanced kind of nature of the shader tree. Maybe, what if you doubled up the geometry? What if you had, because I can see that you're making a little Pokemon ball. What if you had the center of your Pokemon ball be one piece, right? And you can texture map just the eyeball on that. And then you have another ring on the outside that's not associated with the center that you can use.
You know what I'm thinking? Just copying the geometry in front and placing another mesh just a little bit in front.
Just a little bit, that works. No, that's a,
make that transparent, then you can see everything.
yeah, that works. That works. There are a dozen ways to skin this cat, for sure. That's a good option. Okay, questions on how to work with images inside of Modo. Everyone's good? Everyone kind of understand? Okay, so to help you guys out, because I know that there was a lot today as far as content, I've encapsulated pretty much everything that we've talked about today in some videos on renderography.com. So if you go back to the website and go to the resources section, check it out. Right there, down here, there is basically everything that we've talked about. Okay, so I definitely leverage this portion of the website to get you up and running with working with the shader tree. In addition, I've also made a little time lapse on how I textured my corkboard. So if you go back into the homework section, yep, there's a little time lapse that talks precisely about the steps and the procedure of getting images onto your posters for this assignment. Okay, so a lot of additional resources on top of the live stream that will help you work through this if you run into some problems. Yeah.
So we'll be using our own photographs.
Own photographs. Own photographs.
What about the handwritten? What sort of file, like Test Friday on the poster?
Yeah. You can use any image format. Doesn't matter. JPEGs, TIFFs, Targets, PNGs. You can even import Photoshop documents in, which I wouldn't suggest, but you can. You can do it. Yeah. Anything. Does not make a difference. That's one of the great things about working with Modo is that it plays well with others. It does. Really well, actually. Really well. Okay, let's real quick just kind of talk about the expectations for this week. There's two things that you guys are going to be working with, okay, or working towards to complete. First is going to be finalizing the corkboard, okay? You have the geometry done. Now it's just a process of going through and adding materials and image maps to all the elements inside your scene. So everything gets a material and or image map, okay? All the posters that you created have to have an image on that poster, okay? So no blank piece of paper hanging on your wall. Everything's got to have an image on it, okay? So everything gets a material, including the wall, the frame for the corkboard, the actual board itself. Everything gets an image or material, okay? Including the thumbtacks. So don't forget about those thumbtacks, okay? I know they're small, but they got to have a material on them as well, okay? When you're done, we're going to change the render size for this one a little bit. In the previous assignments, I've had you guys render all of your images at 720 by 480. Well, this week we're transitioning to a new render size, 1280 by 720. This is an important number for us inside the computer graphics world. 1280 by 720 represents the pixel resolution of 720p HD television, okay? So I want you guys to leave this course with a number of images that you could very easily include in a portfolio. They need to be big so we can see them really easily, and if you chose to print them, you're now closer to a resolution that would print really well onto an 8.5 by 11 sheet of paper or whatever size you want. Okay? So please make sure you're remembering to do this. Okay? 1280 by 720. Pop quiz. Where can I go with inside the Modo interface to change this number? How do I change the frame height and width of the render? It's under frame properties, yeah? Where do you find that, Francisco? Yeah. What do you have to have selected to get to that tab, though? Render, yeah. I got to have the render, the purple render sphere selected. If you have this guy selected, check it out. Then you're going to get a number of vertical tabs inside your properties window. The first one is called frame. And there it is, frame width and height. Just make sure that's 1280. Next one's 720. Hit return to confirm it. And now we can render an image that's much, much larger. Okay. These are good times. Good times. So 1280 by 720. Here's what's going to happen. Pretty much going forward, everything is going to be at this frame size. Okay? This is going to be the minimum frame size going forward, 1280 by 720. So get used to coming back into this world, into that tab, to change these values. Okay? All right. Questions? All right. This is due by the beginning of class next week. It's worth 50 points. Please make sure at the conclusion of this process you do two things for me. I need you to upload the LXO to the Dropbox like you did at the conclusion of the last assignment. And, of course, I need you to render and save that render as a JPEG before you submit that JPEG to the Dropbox. Okay? So I need two things, the LXO and the render. Please make sure that you're using the naming conventions that I've subscribed down here at the bottom before you upload these assignments to your Dropbox. It makes it a whole lot easier for me on my side to quickly, process all this information and grade it and get back to it in a timely manner. If you don't follow this, we're kind of slowing the machine down a little bit. Okay? I have a couple hundred students that I have to manage and a lot of files. I mean, if you think about it, I got about 200 students that are all handing in they're handing in between 4 and 6 files a week. That's a lot. That's a lot. I'm getting about 800 to 900 files a week that I have to manage. So please make sure you put your name on everything so I can manage it.
You said you grade 900 assignments a week?
Yeah. Yeah, I mean, if you think about it, every class that I teach, almost every single class, each student is submitting 4 files, 4 or 5 or sometimes 6 files a week. 4 times 2, 4 times 200, 800 files. It's a lot. Yeah, welcome to being a teacher. I got to look at a lot of files every week. And some weeks it gets a little overwhelming, and I get a little bit behind. Okay, so that's our homework. Everyone clear on what we're doing for our homework? All right. For our lab assignment, a really fun lab assignment this week, I've given you guys this cool little scene file. This little scene file. And your job is to go through and just to go crazy with it. Apply materials and textures to everything in the scene. Everything gets a material and a texture. Have fun with it, okay? There is no wrong way of doing this. Your grass can be blue. Your sky can be green. No, I'm joking. Just have fun with it. Have fun with it. The whole idea behind this lab assignment is just to get into the habit of selecting polygons, hitting that M key, and then changing the materials, okay? If you'd like, you can see on a number of these objects, the artist has gone in and has found images off of Google or a number of other places and has texture mapped those images onto the polygons in the scene. Have fun with this. Be as creative as you can, okay? One final thing about this assignment. One of the expectations that I have for this project is that you take 2 different renders from alternating perspectives, okay? Because I want to see in the renders that you've done the entire island, okay? So 2 very opposing, alternating perspectives within inside your render, okay? The file's in the resources section. It's at the very top of the resources section. Resources. There it is, Lab Lighthouse Project. and it may or may not download for me. Let's see. Now I can't take credit for modeling this project, okay? Let's see. No, my computer's still wigging out because of the live stream. But please make sure alternating renders from two polar opposite perspectives on the island itself. And just have fun with it. Yes, sir?
Study added material. The person who made this file originally added materials to the rocks and stuff already. I don't see those.
Well, no, they did it during the process of the lab. They went out and found images online, and they applied it to the material, so they associated with the rocks. Okay. Same with the grass and the water. I mean, just have fun with it. Have fun with it. Okay. Be as creative as you can with this assignment. It's just a kind of a mechanical assignment that allows us to get in and start applying materials. Okay.
That water is just taken from an image?
As an image, you got it. Because if you look at the actual geometry in the file itself, it's just a polygon. It's just a whole series of polygons. I'll leave it to your creative brains to figure out the recipe on how to do all this. Okay? Questions? We got about 30 minutes left in class. Let's get to work.